Hello, everyone, and welcome to the OpenFMB 2016 Grid Modernization Summit Demo Preview and Use Case. My name is Gabrielle Puccio, and I'm with SGIP, and I'd like to welcome you and thank you for your time in joining us. For those of you who are not familiar with SGIP, we are a nonprofit industry consortium representing a cross-section of the energy ecosystem that focuses on accelerating grid modernization and the energy Internet of Things. Our members include utilities, vendors, investment institutions, industry associations, regulators, government entities, national labs, service providers, and universities. We have a very diverse population, very active membership, and we're glad that you can join us today. Next slide, please. Before we get started with the webinar, I'd like to take this opportunity to go over some of the logistics. You'll see to the right of your screen a control panel, and you can use that to select the type of audio that you use for this webinar, whether it be telephone or your computer via mics and speakers. You will automatically, all of the participants of this webinar will be automatically defaulted to mute. So I would ask you also, just in case for safety purposes, to mute your cell phones if you're calling in by cell. Also notice that there's a question pane in the control panel, and that you can use to list or post any of your questions at any time during the presentation. And we'll be taking your questions at the end of the presentation during a Q&A period. I would also like to let you know that the slides for today's webinar and the audio will be made available on the SGIP website at www.sgip.org at the end, probably by tomorrow. I would also like to let you know that for those of you who are attending, you will receive a survey from us, and we'd really appreciate if you would take the time to fill out that survey and let us know what you think about the webinar. Next slide, please. So to begin, again, this webinar will give us a preview of what will be happening at the Grid Modernization Summit in November, as well as take us through some use cases that have been the foundation for this demo. Next slide. I would like you to meet the presenters. They're part of our OpenFMB team. Dr. Stuart Laval is a manager of technology development in Duke Energy's Emerging Technology Office. He also serves as co-chair for the OpenFMB team and the various task forces with both SGIP and NASB. Aaron Smallwood is our VP of Technology at SGIP, and he's responsible for leading SGIP's Program Management Office and working with member committees and technical working groups in advancing SGIP's technology strategy and agenda. And with that introduction to our speakers, I'd like to turn it over to Aaron.
Thanks, Gabrielle. I'm Aaron Smallwood, Vice President of Technology at SGIP, and myself, along with one of our industry co-chairs of the OpenFMB Priority Action Plan at SGIP, that would be Dr. Laval. We welcome you to this Open Field Message Bus webinar. A couple of opening thoughts here. It's nice to see you all here, and thanks for coming. So I imagine that some of you are new to Open Field Message Bus and want to build an understanding of what it is. Some of you are familiar with Open Field Message Bus and want to see our new use case that highlights how OpenFMB can be used to effectively manage a circuit with high penetration of DER by using local data exchange, not replacing centralized control, but layering additional intelligent distributed control on top of it. And we'll go through all of that. We're also going to give you a preview of something that we're very excited about, which is our OpenField Message Bus collaboration site. The site is a step towards our goal of OpenField Message Bus adoption by sharing OpenFMB code that's been developed and by also building a community where people can exchange code and information and continue to build new OpenFMB code and functionality. That's what we're going to go through today. Let's get started. Next slide. So welcome and introductions. We're here. The next slide after this, don't advance yet please, is the Grid Modernization OpenFMB demo preview. I have a little preview of what we're going to have planned for a couple weeks from now. We've got an OpenFMB framework overview. We're fortunate to have Dr. Laval here from Duke Energy to talk to us about OpenFMB. We're also going to talk about our distributed energy resources use case. It's new in 2016. It's been a major focus of our OpenFMB group at SGIP. It contains a primary scenario, secondary and tertiary scenarios showing how OpenFMB can be used to manage distribution operations with high penetration of DER. The use case is now complete, and Dr. Laval will walk us through it. Lastly, we'll go through the collaboration site preview. We're going to launch the website at November 7th, right at our Grid Modernization Summit, and I will spend some time giving you a preview of the OpenFMB resources that are available and what you can expect. So we've also set aside some time for Q&A at the end. So jot down your questions as we go through, save them for the end, and let's get started. Next slide. As I mentioned, the official launch of our collaboration site will be at our Grid Modernization Summit on November 7th. In addition to launching the site, we will have it available there at our Grid Modernization Summit. We're having OpenFMB participants hosting demonstrations using the code that's actually available on the collaboration site. So they're using it to show what they can do with their hardware and software and how it can interact and be used with OpenFMB. The demonstrations, the theme behind it all is we're walking through the OpenFMB framework that we've used at SGIP. So as you enter the demo area, we'll see different things highlighting the business case and the use case requirements definition process. We'll talk about the use case development and the data modeling that goes along with those use cases. You'll see some vendors using IoT sub-protocols and some also showing off their hardware and software implementations. So the thought is, for the demonstration, we're going to show with the OpenFMB code that's available on the collaboration site what type of things that can be done with OpenFMB. And we're very excited to show that off. Next slide. So with that said, I'd like to hand it over to Dr. Laval for a quick overview of the OpenFMB framework.
Thank you, Aaron. As you mentioned, this is Stuart Laval. I work at Duke Energy, and I've been very fortunate to be a part of this team at SGIP to really help lead the development of the framework as well as some of the newer use cases that we hope can help drive further adoption of distributed energy resources. Next slide. So just a basic overview of the OpenField Message Bus framework. We get a lot of questions about, what is the OpenFMB? Is it a technology? Is it a solution? It's actually neither. It's reference architecture. It's a framework for distributed intelligence. The intent is really to be a catalyst to drive interoperability. And we can do this by leveraging existing standards in the industry that can help federate data between field devices, but at the same time, harmonize them with our existing centralized systems like our DMS or EMS or other SCADA systems. Two major ingredients of the framework include standards such as the IEC Common Information Model. We use this as really a common semantic or common data model to be shared across the various systems. You don't have to use the Common Information Model. It just happened to be a standard that was available and essentially commonly used in the industry in North America. Another key ingredient is the publish-subscribe protocols, or in other words, middleware. These came out of the Industrial Internet of Things industry. Three standards-based protocols that already exist are Data Distribution Service, MQTT or Message Queue Telemetry Transport, and AMQP, Advanced Message Queue Protocols. And the beauty of the framework, as new protocols are innovated and are available, we can definitely take a look at them and try to, basically add them to the framework. Some of the biggest advantages of the framework for OpenFMB is that you can scale independently. You don't have to require a system-wide rollout or deployment. It really does help, when you want to integrate, interconnect renewables such as solar or wind into the existing power system, and also would help accelerate stack benefits, and which could be a key driver for energy storage. And last but not least, this OpenFMB standard was ratified in March of 2016, and it's available at the North American Energy Standards Board. Next slide. So before I get into some of the details of the OpenFMB framework, I think it's key to outline some of the guiding principles that really help us drive the definition of the framework. The first key point is that we want to make sure this framework is an agile and evolving architecture. One of the common beliefs of a lot of the team members is that there is not a one-size-fits-all technology that can really design for DERs that can help retrofit and integrate the existing power system. And so in order to do that, we need a framework that's flexible enough to handle any data model and any pub/sub protocol. And so we don't want to reinvent the wheel or duplicate any efforts in the standards community. I show a picture, a bubble chart of all the different standards out there today. You can see there's many different options. There's two major standards out there. One is ISD 61850, another one is SIM. It really doesn't matter which one you use for the framework as long as you're consistent across your organization. And this first implementation that we did for SGIP, we used the Common Information Model, which is the IEC 61970 and 61968. Another key thing about the guiding principles is that we're really trying to solve real problems by focusing on business value. Before we solve these problems, we want to make sure that the system design is inherently flexible, scalable, and backward compatible from the start. And that really entails a great security and management services architecture built in at the start. Next slide. So this is really our boilerplate slide where we kind of show the main differences between a traditional SCADA system in the back office and how the different solutions typically are able to share information. On the left, we have different vendor options, and typically they're prepackaged with hardware, telecommunications, and software from a data awareness perspective. And the only way to really stitch them together is in the back office through some type of enterprise service bus. And in this particular paradigm, it's very difficult to get information in the field between devices. If you look on the far right, you'll see that we've broken down these silos, and we took the concept of an enterprise service bus and we put it as far close to the grid edge as possible. Obviously, you see there's some nodes involved. In many cases, a lot of the devices that we already have, such as inverters, controllers, they already have a computer with some type of Linux operating system. And so in many cases, you may not need an additional hardware. You could literally put in a virtual node to allow this type of peer-to-peer communication. Another key ingredient of this framework is that it can run on top of any network, whether it's wired or wireless. And as I mentioned, the key pieces to make this happen is you need a common understanding of the data, or we call it semantic model, such as the Common Information Model, as well as we need common languages or common protocols to speak. And we've identified the Industrial Internet of Things protocols as compliant or compatible options that can enable this flattening of the logic. So we've essentially abstracted the physical, the network, and the logical layers of data using this framework that includes Industrial Internet of Things protocols. Next slide. We have a next slide. All right.
Sorry, just 1 second. There we go.
Okay. All right, so here's another picture to kind of show the federation of messages across the OpenField message bus. Another common question we get is it just one bus? Actually, the answer is logically no. There's actually many buses, and we have what we call interaction patterns. And these interaction patterns really segment and isolate the data exchanges. So in this particular example, we showed a particular use case for a grid edge analytic or some type of, let's say, microgrid or distributed energy resource management system. But in order to pull off that optimization, you have to have a variety of actors that share a common set of parameters. And in this particular example, we show in publish subscribe, we have a interaction pattern called a reading. And in the reading, which is your measurements, these are the set of parameters that are synonymous and germane across all of the actors in this particular use case. So, for example, you may have a common interaction pattern for the reading that has, kilowatts, kilovars, voltage current, phase angle, kilowatt hours, timestamp, and state of charge. And essentially, you've created this greatest common denominator, a set of parameters, which is required for the use case. And then all the other parameters that you can potentially get from these devices are not really identified as relevant for the use case, so you don't necessarily have to put those on the bus. So not necessarily all the data goes on the message bus, it's just the data that needs to be consumed for the analytic. And another, kind of showing another example of an interaction pattern, these are data-driven events. So if you look at the bottom left, we have some type of events, alarms, controls, and the parameters really only needed for that are whether, for example, an islanding switch in a microgrid is open or closed, and its timestamp. And that very low payload is all that's needed on the message bus to get the information the system needs to perform its mission-critical function. Next slide. So this is the logical reference architecture from the NASB standard. And what we've effectively done here is we're abstracting the application layer from the devices. And in many cases, the devices natively speak some type of client-server protocol, such as Modbus or GMP3. You have to be able to convert these client-server to that pub-sub layer. And in order to do that, we've identified an interface layer, which is really how not only you could, can you go back, please? Okay. Can you please go back? Okay, thank you. I think we're on the, can you go back to slide 13, please? Okay, thank you. The interface layer is critical because it helps not only translate from the client server adapters to the message bus, it also maps the data models and profiles to the appropriate configuration of your reference implementation. And in that configuration, you would identify the different interaction patterns, such as readings or controls or events. And you would also potentially even identify security policies or security profiles that are relevant for a particular use case. So as you can see, the very bottom layer is your different pub-sub protocol. The beauty is you can bridge between any of them. So whether you're speaking AMQP, DDS, or MQTT, they can still understand each other as long as they're speaking the same data model, which is a very powerful attribute of this framework. So next slide. So it's not just a flat architecture, it actually is layered. And you can see in this particular example, we have end devices, which is really your legacy protocols that need to translate into the OpenFMB common context, as well as common languages. You would have nodes, either virtual or physical, at the edge. You can also have nodes in your middle tier on the grid or at the substation. And then you could, likewise, you can even have a node in the data center that's really helping bridge and adapt from your traditional SCADA system. Next slide. So SGIP helped define a framework lifestyle, and key point to notice about this framework as it's business-driven, top-down. It's also very iterative, so as each step is enhanced, it will be fed back into the framework and rolled into eventually into the updates in the standard. The business case is what drives the use case requirements, and in many cases they're functions or like operational functions, and then there's we call non-functional requirements. These are really more of your management services such as your configuration as well as security. Once you go from your use case, you need to model it into essentially some type of unified modeling language, which is the standard in our industry for data modeling. We can reference from existing standards like SIM or 62050. To move further along the process, we need to generate that UML or data model profile into an actual syntax that the message bus protocols can understand. So that's where you get into your XML schema definition or interface description language. These are just standards-based syntaxes for defining the payload structure of your messages. And then from there, you'll pretty much get into your implementation details, which include your apps, your adapters. You'll obviously, once you complete your development, you're going to want to validate it and test it in the field. And last but not least, make sure that you continually have a process for updating and revisioning your reference solution. Next slide. So one of the key deliverables that we're very proud of this year is what we call the Distributed Energy Resource Management Circuit Segment Management use case. And in order to really get the value of the framework, you got to have a foundational use case. And that's really what this DER Circuit Segment Management is for. And I'll kind of explain, what are the various primary, secondary, tertiary type scenarios that can derive from this type of DER coordination. Next slide. So one of the things that really helps differentiate OpenField Message Bus is its ability to enable distributed intelligence, and this feature is what's needed for the efficient, flexible, and scalable management of the distributed energy resources, especially circuits with high penetration of solar. Other benefits that kind of come along with distributed intelligence are having a really more reliable, resilient, and secure power system. Another key attribute of the OpenFMB is its ability to provide local device coordination that is harmonized with their existing centralized system control. And it's really moving to this layered distributed energy resource management type paradigm. A lot of the analytics that are needed for distributed energy resources are going to have to be at the grid edge, but they're also going to have to coordinate their self-optimization with the devices that are now collecting a lot more granular data, as well as we're starting to see a lot more devices, physical devices, just being interconnected and integrated into the whole system. So this whole system of systems concept is really what the OpenFMB can enable. Next slide. So in our foundational use case, we wanted to identify a reference implementation to really help explain the coordination that's going to go on the circuit segment. And so in this particular example, what we've done is we've taken a representative circuit, and it was actually Duke Energy's pilot circuit for OpenFMB, where we currently have a microgrid at the very end, and we'll be starting to move this communication framework out to the power system to complement and augment our existing SCADA system, which today is controlled by the DMS. And in this particular example, what we're showing here is that there's a clear coordination or interface that needs to happen between the circuit segment. In this case, it would be the feeder to the microgrid, or it could be your feeder to each interconnected DER. And so in this particular use case, we've definitely coordinated between what's being handled by the centralized DMS and what's being optimized and coordinated with your distributed resources. And so on this particular example, we have essentially 3 distributed energy resources that are interconnected into the grid. And we have 2 acronyms at the bottom. One is the point of common coupling, which is your interface for your microgrid, typically controlled by the customer. And then there's a point of interconnection, which is really owned by the utility, and this is how the utility interfaces with the distributed energy resources. And so, as I mentioned, in this example, we have 3 different distributed energy resources that are being controlled or optimized. The first of which is the microgrid. the second of which is the solar inverter at the very end of the circuit, and the third is the energy storage system that sits right before the circuit breaker in the substation. And so a lot of these will be optimizing, but at the same time be coordinating and staying within the boundaries of your voltage, frequency, and power factor settings at your point of interconnection. So a lot to digest, but what I'll do is I'll take this concept here and go to the next slide and help really explain what are the details in the use case. And this is my last slide. But before we actually went into creating the circuit segment management use case, we went back into last year's microgrid use cases, which were really a self-contained island and microgrid, and we updated it to help interconnect and interface with the power system. So those are some of the things we did to update in 2015. We've enhanced the unscheduled islanding, which is your transition from the grid to an island, a microgrid. We also did the reconnection piece where you're going back from an island to the power system, or your resynchronization. And then we also identified a third use case, which previously was called microgrid optimization, but it's more broadly circuit segment optimization, because whether you're connected to a power circuit segment or a island in microgrid, it should be the same use case. And it's just you're essentially using market, weather, forecast, dispatching your various generation resources as well as potential controllable loads. So let's get into the actual foundational use case called the DER circuit segment management. And as I mentioned, the primary scenario is to ensure that your point of interconnection and your point of common coupling are actively coordinated with the utility power system in a fashion where it doesn't conflict with your existing centralized management and optimization. Some of the key areas or parameters that are given essentially boundary conditions and given schedules at the point of interconnection are voltage, frequency, and power factor. As long as you stay within those boundaries of the primary scenario, then you can start to consider doing some additional performance based use cases. We call these secondary extensions. This would include solar smoothing, where you might have a battery that can help dispatch, power or VARs to reduce the volatility on your circuit segment that's being, basically impacted by solar spikes. Another extension would be volt VAR management. This would really help you get unity power factor at the point of interconnection across your circuit. So it really doesn't really compete or affect the conservation voltage reduction that may be centrally managed in 5 or 15-minute intervals by your DMS. And peak demand. This is where in some cases it may make sense to have some type of ramp rate control, do some shaving or some energy shifting if you have excess battery capacity. And last but not least, these tertiary extensions. These are really use cases as really a safety net, just in case when you're starting to have a high penetration of solar and you have a lot of bidirectional power flow, your existing protection schemes that were designed for a one-way power system are not desensitized by the high penetration DER. So in this case, we would expect that your reclosers, your switches would be able to detect anomalies and losses of power, but in some cases where you have too much solar and bidirectional power flow, you may not see that fault. And in that case, you would have a third use case that could provide really a tertiary measure to ensure that the fault was identified and shared across the message bus and all the different reclosers on that power system. And then last but not least, there's another phenomenon that's very rare that we wanted to account for as another safety net, and that's really we call inadvertent island detection. This is cases where there could be deviations in frequency across your power system, and we want to make sure that devices have intelligence to be able to coordinate, and if for some reason there was an islanding event upstream, that the systems that were out of balance would essentially protect themselves. So that pretty much concludes the foundational use case, and with that I will pass it back to Aaron.
Thank you, Stuart. Great overview. Next slide, please. There we go. I want to talk to you a little bit about our collaboration site. So a little bit of history on it. We developed this site as a way to make OpenFMB information available to industry, and to public, and really anybody who's interested. As we spoke at events about OpenFMB, there was a recurring request. I was like, how do I get more information? How can I see the code? How can I download the code and get my hands on it and better understand how it works and how we can use it? So we built this site to address those needs. As I mentioned, this site will be formally launched on November 7th, the beginning of our Grid Modernization Summit here in just a few weeks. Next slide, please. And this is just a preview. I wanted to give you a flavor for the types of information and what's involved in the collaboration site and what you can expect to get there. To do that, draw your attention to the navigation bar in the top right-hand corner of the screen. You see we have a section for OpenFMB overview. There's information there. Background information similar to what Stuart just went through. Will be easily consumable. It provides information to newcomers and veterans about what OpenFMB is, how it works, what its goals are. And going off to the right, there's information also about the OpenFMB Model Business Practices Standard by NASB, and how you can get a hold of the standard and how we do updates to the standard. We also have resources available, resources including OpenFMB related publications, use cases we just reviewed. Those will be there, and a use case library that will be available, and upcoming OpenFMB events. We are planning to use this site to establish an online OpenFMB community as well. We'll have an OpenFMB blog, informational wikis, and ways for the community to interact with one another as we move forward. And lastly, you can see that one on the right, OpenFMB code. We have the OpenFMB code itself, which is we're really happy to provide in three main pieces. The OpenFMB code will be hosted on an OpenFMB GitHub site, which, if you're familiar with GitHub, is a very effective and great way to host open source software. It allows people to not only download the code, but in return share additional code that they've developed. Our intent is, and I think this is key, as we make this foundational set of OpenFMB code available, that developers and vendors and people in the community will use this code to build upon and create an active OpenFMB open source community. Next slide. I'll give you a taste for what some of the different sections of code and types of code that we'll have available on the site. The first one I call the OpenFMB Developers Toolkit. This set is a downloadable turnkey executable file, and once you download it, you'll be able to extract and install it, and you'll have an OpenFMB implementation largely ready to use. Along with the code comes a full set of instructions and how-to information. So there's a lot of background information there to understand and get through, but it will all be there to walk you through it. This set of code is built to be ready to use. It's based on the same code set that was used in the OpenFMB microgrid distribution demonstration at Distributech 2016. That demo was very successful and viewed by thousands and thousands of people with great reviews. It had a lot of excitement at DTech if you were there that year. So it's the same code itself, but it's been simplified and, for lack of a better term, anonymized with specific information types, equipment types, and information excluded to make it more generic and applicable to what you would want to do with it. But it's the same base code set. It also comes with instructions and a wiki and a README file and ready information ready for it to go. That's the Developer's Toolkit. Next slide. And as we go through these, you'll see that they get a little bit more detailed, more advanced as we go through. Next is a full version. The second set of OpenFMB code contains, not as a wrapped up individual package, but in different pieces, parts and pieces, has the OpenFMB demo code. In addition, it has OpenFMB adapters for DMP3, there's Modbus, there's others. And it's available for three protocols, MQTT, DDS, and AMQP. This also comes with README files, wiki, and configuration instructions, everything you would need. This is designed for someone who wants to dig a little deeper into the code and find out how OpenFMB works at a technical level and begin to explore what and how they might develop new code and new functions for OpenFMB. So that's there as well. Next slide, please. This is the DIY, the do-it-yourself OpenFMB code for advanced users. So this contains all of the code previously mentioned on the last two slides, broken down into pieces that you can manipulate and configure yourself. And there's a lot more parts and pieces that you can plug in with each other to do what you'd like with OpenFMB. Once you have a base familiarity with the OpenFMB code set, you could use this to explore security, experiment with scaling OpenFMB. You can pursue additional use cases yourself with OpenFMB. You can install multiple instances. It comes with additional tools as well. There's a load simulator. You can see some of the pieces at the bottom there in the last bullet points. It's a screenshot from the GitHub itself. You have simulators, a human-machine interface. There's a adapters library. In QTT, there's load publishing software. There's the three protocols there at the bottom, DMP3, Modbus, and MQTT. So this is the library of information that once you really understand what's going on and you have a specific use in mind that you can explore, you can see how adapters were written to work with different protocols at OpenFMB and how pieces of equipment were, how software was written to help connect different pieces of equipment and how it might be done for additional things that haven't been done yet. So this is examples with instructions and a little bit of know-how from the developers that have worked on this OpenFMB code set so far to get you pointed in the right direction and help you on your way. We're excited to share this with industry and the community, but we're also just as equally excited to see what people do with it. So one of the benefits of having the GitHub in the community is if you're a vendor or an interested researcher wanted to try and use OpenFMB in a new and different way or extend it to a use that hasn't been conquered yet, and there's a whole landscape out there to be addressed with OpenFMB, you can bring that information back and share it with the community and add to this library of OpenFMB code. Next slide, please. Lastly, we have community and resources. So I mentioned this briefly before, the use cases. So detailed information about use cases, what use cases have been completed so far, including the UML that describes the use cases, step-by-step narrative scenarios that walk through how the use cases were designed. The two main ones we have so far are the DER circuit segment management use case that Stuart just walked us through a few minutes ago. We've retrofitted the 2015 microgrid use case to update it for changes to OpenFMB. Those will be there, and as new use cases are developed, we'll post them here on this website as well. Publications will be there. The technical white papers, articles, interviews, upcoming OpenFMB related events, information about reference implementations. So there have been several so far. This is a way for us to communicate to them. For instance, if there's a utility or a vendor or a group of academic institutions who are doing an OpenFMB implementation as part of a research project or just to explore the pieces and potentials there, we can provide information about that and who to contact if they're willing to participate. Next slide. A little bit about the launch. So as I mentioned earlier, we're excited about this site. We're anxious to get the code in the hands of people that are interested and see what people do with it and be able to interact and answer questions with the community. We are launching this on November 7th at the 2016 Grid Modernization Summit. Not only are we launching the site, but at the Grid Mod Summit, you'll see participant demonstrations from our participant vendors who are utilizing that same code that I just showed you to do different things there. I'm at the Grid Modernization Summit. We're also at that conference having an in-person meeting with the OpenFMB team, and it'll be an opportunity for you to network with OpenFMB experts. Following on to that, next slide. After the site launches and you've had an opportunity to review the information, become familiar with the use cases, depending on your level of interest. Once you've had a chance to experience everything we have there, we're following that up with an informational webinar on the 17th of November. So mark that date. We'll be walking through in some detail each of the sections of the site, and we'll have OpenFMB and technical experts available to take questions that you have. So if you're interested, save that date. It'll be a really good opportunity for you to explore and discuss things that you might want to do. And the next slide, which is the last one for me for this section, is how to learn more and participate. So to learn more about OpenFMB and to join SGIP, there's the contact link in the bottom right-hand corner of the slide. You can just go to the SGIP website and click on the Contact Us piece. learn about how to join SGIP, how to join and participate in OpenFMB. If you're interested, we'd love to have you at the Grid Modernization Summit. There's also information on our website about how to attend that. But regardless, please contact us if you have any questions at all. So that's my preview of the collaboration site. You'll see more information about it in the coming weeks. There'll be a press release about it and information posted on our website. Please let us know if you have any questions. So that concludes the content that I have and that Stuart and I have. Gabrielle, if we have any questions, I can hand it over to you to facilitate the Q&A session.
Yes, thank you, Aaron and Stuart, very much for a very comprehensive look at where we are with OpenFMB right now and where we are going, especially with the collaboration site and the repository and the exciting opportunity that we have for the OpenFMB demo in November at the Grid Modernization Summit in DC. We're looking forward to that. And we do have questions. Hold on one second. Let me start at the top. Okay, the first question is, does OpenFMB also apply on the other side of the meter, such as streetlights that are connected to the grid? And how does it help make smart cities that want all kinds of IoT like video and more and different applications?
You want to take that one?
So I can take that. Yeah, sure. I'll take that. So the question really is kind of twofold. I think the first one is really, can it apply behind the meter? And the second one is really related to, can it apply to really other types of use cases and such as smart cities or video data. So the first part, can the framework be used behind the meter? The answer is yes. The reference implementations today have been led by utilities, and at least the first reference implementation, that was a regulated utility where they pretty much stop at the meter, and that was the reason why we didn't go beyond the meter. But using the framework, using the top-down business-driven approach, you can definitely use profiles and data models for behind-the-meter actors. There's a lot of standards out there today, such as Open Automated Demand Response is one. I know Voltron from the DOE, I think, did a lot of building automation type systems, and so it's actually very possible. Just like we did a layered approach for circuit segment management, there's no reason why there can't be a common interface between behind the meter applications and the power system, or behind the meter applications to smart city applications. So it's really the same framework, can apply at really any vertical, and even beyond the energy industry. The second part of the question was really related to different types of data like video data. So most of the use cases that we've done for operational control functions really are using structured data sets, like voltage, current, timestamp. Video data is a lot more unstructured and it's a lot more granular. So there may need to be some type of adapter or some type of filtering process that can at least convert that unstructured data stream, like a video data, into something that's metadata, which can be structured and understood between the various actors on the message bus.
Thank you, Stuart. Okay, another question is, can the framework interoperate with other semantic data models such as those provided by the Open Connectivity Foundation?
So I'll take that as well, Aaron.
Yeah.
So I'm not really familiar with the Open Connectivity Foundation, but the short answer is, with the framework, you can define modular sets of profiles, and it's just a matter of mapping between the various semantics. They can be done in UML, or potentially they could be done even at some of the protocols. It really depends on your implementation details, but ideally it'd be best to probably map to a common UML data model profile. So we're trying to pull those into UML, maybe the probably the simpler way to manage and administer and generate your OpenFMB profiles.
Thanks. Okay. So guys, where does security fit within the OpenFMB architecture?
Well, security right now, I'll take this one, Stuart, and you can jump in and add more color to it if you would. Right now with OpenFMB, we have a cybersecurity task force that's been reviewing. Now, so the OpenFMB security that's involved in the reference implementation has been using DDS. What we're doing right now as a group at SGIP is exploring what the OpenFMB cybersecurity roadmap and security architecture needs to look like, so we can build upon and push that one forward. That will take the form of a cybersecurity roadmap. We're using several industry sources, IoT type sources to build that view of what that is. We're looking at everything from security policies at a high level, from a top-down view, down to very detailed adapter-specific security protocols to be used in the communication. Stuart, do you want to add anything to that about security?
Yeah, so I mean, as Aaron mentioned, we're building in security really across the entire implementation, and we're really trying to make this really end-to-end and unified across the different layers, whether it's software, hardware, telecommunications. Just like we have a framework to generate operational functions, for example, like a microgrid optimization, there would still be a use case for really building out security use cases or security policies. And there may be security-specific profiles or topics or semantic, and as well as behaviors. Some of the protocols, as Aaron had mentioned, have different levels of security. I believe all of them can all be transport layer secure, TLS type security over SSL at a bare minimum, to at least have some type of network security to encapsulate the payload. Some other protocols, such as DDS, have the ability to not only whitelist but also to encrypt the actual payload itself. So it really depends on your use case, what requirements you have. You could have a finer grain of encryption or authentication, as well as potentially in the future, some type of intrusion detection, or even some type of machine learning, which will really be able to detect, isolate, and restore based on domain knowledge. But that's probably more of a 2017, 2018 type activity. There are other activities that are trying to align to the best practices in the industry for security. I know that EPRI, or the Electropractical Research Institute, is working on an ontology for configuration for security, and they're actively working with the OpenFMB to try to roll that into the framework.
Okay, great. Here's another question. Have use cases been considered for coordinating non-unity DER power factors with feeder volt VAR schemes? Mitigating voltage rise with VARs and CVR appear to have conflicting objectives.
So that's a very loaded question. To be honest, that's a lot of information to swallow. I don't really know. I can't really comprehend the question more than just saying that, when you build out your use case, one good practice is to actually simulate the interaction patterns, before you actually implement on your power system, so that you can start to identify any potential, competing resources or competing systems. But I think the way we've identified at least the circuit segment management, our intent was that the edge control would not compete with the central control. because the central decisions are typically made in 5 to 15-minute intervals, whereas the edge devices can be done locally and are done in seconds, in some cases fractions of a second, which are just really coordinating and augmenting the centralized volt-var optimization. But to answer the question, I think simulation is good practice, and I would recommend doing that before trying anything complicated.
Thanks. Here's a question. Are the adapters using OpenDNP libraries?
So there are the adapters that are on the repository. I believe they are open source, and I don't know the exact flavor, but I'm thinking they are probably an OpenDNP type of implementation. And I do believe the actual DNP 3 stack is OpenDNP. So I believe that you have to have the DNP stack as well as the adapter, which converts that from client server to pub sub.
Okay, we do have another related question. Are vendors, specifically vendors like SNC, SSN, actually providing those adapters that could be leveraged?
I believe the adapters today are members of the SGIP and members of the OpenFMB team. And I'm not familiar with either of those companies are either members of SGIP or members of the OpenFMB team.
Right, that's correct. The answer's correct.
Okay. What types of businesses or market segments should implement the use of OpenFMB?
I mean, I think it really. Go ahead.
Go ahead.
You go ahead, Aaron.
I was just going to set the table. Maybe you can finish it up and say the potential is large, right? I mean, within the utility space. Was the question specifically about what type of vendors within the utility and energy space, Gabrielle? Could you say it one more time for me, please?
Okay, it was what types of businesses or market segments should implement OpenFMB? Should implement OpenFMB. Well,
yeah. So let me just say that it's a framework, and I think like any framework, you really need to have a business problem you're trying to solve, and I would say that it really depends on what the value that use case is going to bring to that business problem you're trying to solve. A lot of the problems that we've tried to solve in the first round of OpenFMB are really new use cases that the current system really wasn't set up to handle, such as sub-second decisions at the edge with bidirectional power flow. So these are kind of the new disruptive drivers for change, and that's why OpenFMB just happened to be a tool in the toolkit to help implement and innovate quickly. But there's not you theoretically could go back to your current infrastructure and start to perform, go through the framework and start to, try to enhance your existing infrastructure, but the business value may not be as, critical as, say, some of these newer use cases that are evolving that may not have, tools in the toolkit.
Thank you. Here's a question, I believe, on the repository and the code. The question is the spec only available to SGIP members, and under what open source license will the OpenFMB code be made available?
Sure. So the code, the collaboration site, is publicly available. It's available for anyone. You don't have to be an SGIP member to access the code. So no, you don't have to be an SGIP member. We'd like you to be. There's additional benefits to being an SGIP member, which is interact at a little higher level with new pieces of use cases and information as things are developed. The question about the license, we're using an Apache 2 open source license, using it for SGIP information. So it's common. It's a typical open source license based on Apache 2 that you would see in many open source implementations.
Okay. But so just to clarify, Aaron, this is going to be publicly available. You have the licensing in place, but it's not available right now. It's going to be introduced or launched at our GridMod Summit, where you guys are going to be setting up with additional collaborators to provide an OpenFMB demo within the vendor expo. Is that correct?
Yes, so the participants in the demo are our partners at SGIP, from vendors and utilities who have used OpenFMB, and their pieces in the demonstration will be utilizing this repository code, right, that's going to be on the collaboration site to solve different business problems and show how their products and services interact with OpenFMB. So yes, you're exactly right.
Okay, so we'll actually get to see some of the collaboration and the use of the repository and the collaboration site live at the conference.
That's correct.
Okay, and how is SGIP working to bring this community together? Currently, are there any working collaborations between DOE, DOD, and the industry? Can you give examples of some of the collaborations and partnerships, who's involved? Can you tell, or do you don't want to tip your hand?
No, I think it's a fair question. Right now, our primary means of interfacing with industry and the community is through SGIP. So join SGIP and you'll be able to participate in our priority action plan, or our way of saying our working group, that's utilizing OpenFMB and putting together use cases and demonstrations. But that said, OpenFMB is not owned by SGIP. It is a reference architecture that's a standard ratified by NASB. So we're a group that believes in OpenFMB and would pursue OpenFMB, and are making these resources online available to encourage adoption and usage of OpenFMB. So, do you know of any others? Yeah,
just to add, I mean, SGIP has done a great job, documenting and really facilitating the test beds, and in that, of the various OpenFMB implementations, a few of them are Department of Energy labs. We have a number of participants, from, for example, the NREL, National Renewable Energy Lab, Oak Ridge Labs. I believe Pacific Northwest Labs is participating in one shape or another. So a lot of these, DOE, types of programs are actively participating in OpenFMB, and I actually believe some of the latest funding opportunity announcements have now referenced OpenFMB as one of the standards that they would like to, essentially award some grants to. So you can see that there's a lot more interest, and it looks like many of the various government labs are starting to embrace this framework.
Very good. Well, thank you. We are at the top of the hour. I would like to thank all of our participants in today's webinar. Again, the audio and the slides for today's presentation will be available on the SGIP website, and you've seen that in your chat windows. I'd like to thank our esteemed speakers for their time and for taking us through what we can look forward to seeing this in just a few short weeks in November. And I'd like to invite all of you to the 2016 GridMod Summit, November 7th through the 10th, to see all of this live. And I did place those links in the chat windows. Thank you all again. Don't forget that there's a survey to take that you'll receive immediately following. And we look forward to seeing you all again November 17th when we go through the repository live. Thank you. Thanks, everyone.